Okay, in this video we're looking at absolute value functions. They're not found in a lot of books, but they are part of our achievement standard. So absolute values. An absolute value is often used in distance. The distance from 0 on the graph may be -2, but we only regard distances as positive, so we would use an absolute value, and we write it like with straight sides on our brackets. So y equals an absolute x. An example of this would be, for example, 10 minus 17 is normally -7, but when I put these brackets on, I'll get a +7. If I have a -1 plus a -2, normally it would be -3. I'll put absolute brackets on it and it will be +3 is my answer here. So that's a use of absolute brackets, absolute values. And let's go back. So the graph, you'll recognise it because of its V shape. Normally, if this is y equals x, it would carry on. I'd have the point 1. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. Normally, I'd have if x is -1, y is -1. If x is -2, y is -2. And the graph will continue in a straight line. But with absolute values, when I go like this, I'm saying when x is -2, then y equals 2. When x is -3, y equals +3. So my points from -2 go to 2, -3 to 3, -1 to 1 here. And we get the sharp V shape. So this graph is y equals absolute x. You'll notice it's going up. It hasn't been stretched or the gradient changed. It's going up 1, 1, 1, 1, 1 across 1 up, 1 across 1 up. My gradient is 1. If we look at the domain, we talked about domains today. The domain on this graph, our x values, it starts, let's do it in red, our graph starts over here at x is -4, goes down, comes up again, and it finishes at x is equal to 4. So the domain, my x values go from -4 up to +4. So the domain x is greater than, I put the bigger n to open end to the x, greater than or equal to -4, and x is, the top is 4, so x is less than, I put the small end of the x, less than or equal to 4. That's my domain. Okay, so that's all I can say about that graph. It's also symmetrical. I could write about that. And the line of symmetry goes down the middle here. The line of symmetry. If I look at these points, this point, let's go to black. This point here is x is 0, y is 4. This point here, x is 0, y is -3. So this line down the middle here, x is always 0, 0, -3, 0, -2, these points. So symmetrical, the line of symmetry is x equals 0. That's my mirror line down the middle. We'll look at this one here. I can see it's an absolute value graph because of the triangle shape. Absolute value. Now it hasn't been translated because it's still at 0, 0 there. But it has been inverted and turned upside down. So we still have y equals absolute x. but because it's been inverted, there's a negative in the front. Just like your parabolas, when they're upside down, there's a negative in front of the x. And you can see the gradient hasn't changed. It goes across one, down one, across one, down one, across one, down one. So it can stay like this. It hasn't been translated. We can talk about the domain again. My x values go from -4 up to 4. So my domain, just get used to writing this, goes from -4 to x to 4. Now x is greater than or equal to -4. The greater than, the open part of the arrow goes to the x. X is greater than or equal to -4. X is less than or equal to 4. Right. We have a positive, it's an absolute, we can write absolute value graph. Now this one has been translated from 0, 0 here. The vertex, we can say the vertex here is at 5 is my x. We always write our x first. 5, -3 is the point of the vertex. So it's moved 5 across. Okay, it's gone 5 across and it's gone 3 down. So just like your other graphs, like your parabolas, y equals, now, and we're going to put our absolute marks in here. It's gone to the right 5, so it's x minus 5 in brackets, and it's gone down 3, so I put -3 outside the brackets. Now we can see this is not across 1, up 1, it's across 1, up 2, across 1, up 2. So the gradient has changed in the front there. My gradient value is now my rise over my run. You remember doing that last year for a straight line graph. Your rise over your run, my rise going up 2 here, and my run is just 1. So my rise over my run, so we can look at gradient equals rise over the run from graphs last year. My gradient is 2 over 1 now. I've got an absolute x minus 5, take away 3. And again, you can do the domain. Let's do the domain in black. The domain runs from 2 until 2, 4, 6 to 8. So the domain is from 2 to 8, the x in the middle, greater than or equal to, like that. And that's that graph, a translated graph. Again, the A here is my gradient. This is where it's moved sideways, and the -3, -3 is how many it's gone down. Look at for these absolute graphs. This one here, now let's see, it's y equals, it's an absolute graph. I know it's, now it's not across 1, down 1, so I've got some value of A, some gradient change here, which has stretched it, and my absolute value is going to be x. I've moved across 5 to the negative, so I'm going to put +5 in the bracket, and it's moved down 3, so -3 on the outside. Sorry, that's a minus. Now, how do I find A? My rise over my run. Rise is 1, run is 2. Okay, or we can go this way. My rise, I'll do that in red. My rise is 1 and my run is 2. But pick 2 points on the line. Any 2 points. I can pick these 2 points here. Between those, I have a rise of 1 and a run of 2. So rise over 1 is 1 over 2. Y equals an absolute x plus 5 absolute minus 3 is the equation of that. Now this one is cut off in strange places. So from here, my graph goes from here to here. So my domain for this graph goes up to the x line, 5, 6, 7, 8, negative 8, and to 0. So my x goes from negative 8 to 0. X is greater than or equal to that. That's my domain. X is a real number. And I don't have a mirror line on this one, do I? Because that's an uneven kind of graph. Okay, and that's it for absolute value graphs. I hope that helps you.